Alright, good day class. You are welcome back to mathematics class. Today we are going to continue from where we stop in our matrices, and we are going to begin today's class by looking at scalar multiplication. Okay, so a scalar is an ordinary number just like 2, 3, 4, 8 and 9, and when you use it to multiply a matrix, so that is what we call scalar multiplication in matrices. Okay, so let's take a look at some examples. Now the first example here is when we are given a scalar 3 and we are told to multiply it with 1, 2, 3, 4. Okay, so this is a matrix and this is a 2 by 2 matrices, and we are multiplying it with 3. Okay, now what we are going to do here is just to multiply all the numbers inside the bracket with 3. Okay, we did this in our previous class. Now 3 times 1 will give us 3, 3 times 2 is 6, 3 times 3 is 9, and 3 times 4, that would be 12. Okay, so and this will be the final answer to that question number 1. So let's take a look at number 2. So when you have 2 multiplied by this 1 by 2 matrix, 5, 7. So as usual, multiply all the elements in the brackets with the 2 outside. Then 2 times 5 will give us 10, 2 times 7 will give us 14. Okay, so that is the answer to that. Let's take one more. Now minus 1 multiplied by 3, 2, 4 and 5. Okay, so what we are going to do here is to multiply everything inside the bracket with minus 1. Okay, when we do that, we have minus 1 times 3 is minus 3, minus 1 times 2 is minus 2, minus 1 times 4 is minus 4, and minus 1 times 5 is minus 5. So and this is our answer to that question. So this is what scalar multiplication is all about, as simple as you are seeing it on the screen. Okay, so now let's continue to look at matrix multiplication. Now we are going to look at this example. The question says if A is given as what you are seeing on the screen and likewise B, find A times B. Okay, solution. So A multiplied by B will be equal to A is given as this, and then B is given as E, F, G, H. Okay, so how do we multiply this together? So this is how you go about it. You are going to use the row, this first row, to multiply this first column in this second matrix. Is that okay? Then after that, we are going to take this second row, we use it to multiply this second column as well. So that is how we do multiplication under matrix. Okay, so let's begin. So A times E, that will give us AE, then plus B times G, that will give us BG. Okay, so we are through with the first row, using it to multiply the first column. So alright, so we are going to take this first row as well, we use it to multiply this second column. Okay, so let's do that very quickly. So A times F will give us AF, then plus B times H, that will be BH. So we are through with those ones at the top. Then next we are going to pick this second row here. We are going to use it to multiply the first column here. Understood? So let's do that very quickly. So C times E will give us CE, then plus D times G will give us DG. All right, so we'll still take this second row here, use it to multiply the second column here. Okay, so let's do that very quickly. C times F will give us CF, then plus D times H will give us DH. So that is just the pattern. Once you understand that pattern, then you don't have any problem multiplying matrices together. Okay, so let me still go ahead and give you one more example, and so that you understand it better. So this question says multiply these two matrices together. So solution. Okay, so let me rewrite it as this. We have 1 2 3 4, and we have here 5 6 7 and 8. Now I told you that when you want to multiply a matrices of this nature together, just take the first row here, use it to multiply the second or the first column in the second matrix, like that. Okay, so let's pick it. So now we are taking 1 times 5, then we now take 2 times 7. Okay, so that's just the pattern. Let's go ahead and write here. So 1 times 5, let me just write it out. 1 times 5, okay, plus then 2 times 7. So we are through with that. We will still pick this first row here, use it to multiply the second column here. Okay, so that means we are going to use this one to multiply this 6, and this 2 will multiply this 8. Is that okay? So let's go ahead and do that. So we now have 1 times 6 plus 2 times 8. So we do for the second row. This second row, we use it to multiply the first column here. Okay, so let's do that quickly, meaning that we are going to take this 3 to multiply this 5, and then we take this 4 to multiply this 7. So let's do that. So we now have 3 times 5 plus 4 times 7. Then we still take this second row, use it to multiply the second column here. Okay, so just like we have done earlier on, just take this 3, use it to multiply this 6, then take this 4, use it to multiply this 8. Okay, so we have 3 times 6, then plus 4 times 8. Okay, so I come down to explain it for you this way, so that once you get it, you'll be able to run with it on your own. Understood? So now the next thing is to multiply those numbers together, one after the other. So let's do that together very quickly. 1 times 5 is 5, then plus 2 times 7 will give us 14. Okay, then 1 times 6 is 6, then 2 times 8 is 16. Okay, so the down part, 3 times 5 will give us 15, plus 4 times 7 will give us 28, then 3 times 6 will give us 18, plus 4 times 8 will give us 32. Okay, so now let's add it together. So 5 plus 14, that will be 19. Then 6 plus 16, 22. 15 plus 28, that is 43. And then finally 18 plus 32 will give us 50. Okay, so and this is the final answer to this question. Okay, so in our next example, I may not slow down to explain how to multiply matrices together, because in this example I have shown you how to multiply together, showing you the pattern. Don't forget, the pattern is the first row multiplied by the first column, Then you take the first row again, use it to multiply the second column. Then you do the same thing to the second row. Okay, so now let's continue. Let's solve this question together. The question says, given that A is as what you can see on the screen and B is given as what you are seeing on the screen, then find Roman figure 1 A times B, 2 B times A, 3 is AB equal to BC. We are going to compare our answers in Roman figure 1 and 2 together to answer that. Then 4, what is your conclusion as a result of your answer in Roman figure 3? So let's begin. Solution. We are going to begin with the first one, which is Roman figure 1. AB is equal to, so what is A? A is given as 4, 3 minus 2 and 5 times B, and B is given as 1, 6, 2 and minus 7. Now let's quickly multiply together following the same pattern I showed you in the previous example. So if you follow that pattern, we'll now be having 4 times 1, okay, plus 3 times 2. Okay, we have taken this first row to multiply this first column one after the other. Okay, so let's continue. Then still the first row, we want to use it to multiply the second column in the second matrix. So we now have 4 times 6 plus 3 times minus 7. Okay, so the second row, we use it to multiply the first column, that is minus 2 times 1 plus 5 times 2. Then the second row, use it to multiply the second column, that is minus 2 times 6 plus 5 times minus 7. Okay, so now let's multiply together and see what we have. 4 times 1 will give us 4, then plus 3 times 2 is 6. 4 times 6 will give us 24, then plus 3 times minus 7 will give us minus 21. Okay, so minus 2 times 1 will give us minus 2, plus 5 times 2 is 10, then minus 2 times 6 is minus 12, then plus 5 times minus 7 will give us minus 35. So let's add and subtract and see what we have. So AB will now be equal to 4 plus 6 will give us 10. Then 24 minus 21 will give us 3. Then minus 2 plus 10, that will give us 8. Then minus 12 minus 35 will give us minus 47. Okay, so this is the answer to Roman figure 1. Then Roman figure 2, we want to find the B times A. So B times A will be equal to 1, 6, 2 minus 7, then multiply by 4, 3 minus 2 and 5. So let's multiply this together. Well, because of space, let me go to the next page and do that. Let me rewrite the question here. B, sorry, okay, so let me rewrite it here. B A will be equal to this 1, 6, 2 minus 7. Then we have 4, 3 minus 2 and 5. So now let's multiply together. So the first row, as usual, multiply by the first column. Okay, and that will be 1 times 4 plus 6 times minus 2. Then the first row again multiply by the second column, that is 1 times 3 plus 6 times 5. Then the second row multiply by the first column, that will be 2 times 4 plus minus 7 times minus 2. Then the second row multiply by the second column will give us 2 times 3 plus minus 7 times 5. So now let's quickly multiply this together before we add. 1 times 4 is 4 plus 6 times minus 2. So 6 times minus 2 will give us minus 12. Okay, now 1 times 3 is 3 plus 6 times 5 is 30. Then 2 times 4 is 8. Minus 7 times minus 2, that is plus 14. Then 2 times 3 is 6. Minus 7 times 5, that is minus 35. So let's carry out the simple addition and subtraction, so that we have 4 minus 12. 4 minus 12, that will be minus 8. Okay, 3 plus 30, that is 33. Then 8 plus 14, that will be 22. And then 6 minus 35, that should be minus 29. Okay, so that's a Roman figure number 2. Now Roman figure 3, the question says, let's go back to the question. So the question says, is AB equal to BA? Now see what we got for AB. You see what we got for AB, compare it with what we got for BA. Is it the same thing? So that's what we want to do next. Okay, so Roman figure 3, the question says AB. Now as you can see for yourself, you will notice that the answers that we got for AB is not equal to BA. So we'll conclude and say AB is not equal to BA. Understood? Okay, so Roman figure 4. Roman figure 4. So the question Roman figure 4 says, what is your conclusion as a result of your answer in Roman figure 3? So what is our conclusion? So we are going to conclude that matrix multiplication is not commutative. Okay, so unlike the addition and subtraction, they are commutative. That is, you can either bring matrix A first and add it to matrix B, or you bring matrix B first and add it to matrix A. You will still get the same answer. But in multiplication, if A comes first and you multiply with B, the answer you get will be different from when B comes first and you multiply with matrix A. So that is what we are talking about here. So I will just conclude and say that matrix multiplication is not commutative. All right, so that is the final answer to this question. Now let's take a look at this last question for today. The question says, given that matrix K equal to what you are seeing on the screen, find the matrix K square plus K plus I, where I is the 2 by 2 identity matrix. Okay, solution. So by now we should know what 2 by 2 identity matrix is all about. While we were looking at addition and subtraction of matrices, we discussed about that. Okay, so solution. Let's first of all find what K square is. Okay, we are given that K is 2, 1, 3 and 4. Then k square means we are going to multiply k with k again. So 2, 1, 3, 4. So let's quickly carry out this simple multiplication before we will now go ahead and add together. Okay, now let's go ahead and multiply. So the first row must multiply by the first column will give us 2 times 2 plus 1 times 3. Okay, so 2 times 1 plus 1 times 4. So I know by now you understand how this multiplication goes. So I will be a little bit faster here. So the second row multiplied by the first and the second column in the second matrix will give us 3 times 2 plus 4 times 3, then 3 times 1 plus 4 times 4. Okay, so and when we multiply we get 4. 2 times 2 is 4 plus 1 times 3 is 3 plus then 2 times 1 is 2 plus 1 times 4 is 4. 3 times 2 is 6 plus 4 times 3 12. Then 3 times 1 is 3 plus 4 times 4 is 16. So let's add this together. And adding it together we get 4 plus 3, that is 7, 2 plus 4, 6, 12 plus 6, that is 18, and 16 plus 3 is 19. Okay, so that's our k square. So we now come back to the question and say therefore k squared plus k plus I will now be equal to, what is the value of k squared? That's the answer we just got, which is 7, 6, 18, and 19. Then plus k, and k is giving us 2, 1, 3, 4. Okay, then plus I. What is I? I is 2 by 2 identity matrix, and that is 1, 0, 0, 1. So that is 2 by 2 identity matrix. Here we come to addition of matrices. So we have learned this before. Everybody should know what to do at this point. So let's add all these matrices together. Doing that, we have 7 plus 2 plus 1. Then we also have 6 plus 1 plus 0. Then we have 18 plus 3, then plus 0. We have 19 plus 4, then plus 1. Okay, so let's add together. 7 plus 2, 9, 9 plus 1, 10. Then 6 plus 1 plus 0, 7. 18 plus 3, 21. So 19 plus 4, that will be 23 plus 1, 24. Okay, so this is the answer to the question, as simple as you have followed through to this point. All right, so this is where we are going to end today's class. If you are yet to understand this, just take your time to play this video again. I trust you that you are going to get it. Thank you for watching. Bye.